and the tangent line. So a couple of things to note here is that because of the way implicit functions can work, it is possible that we have a function, an implicit function, that looks like this. So if I want to find the tangent at A, it is quite possible, or it is, that there could be multiple answers for any tangent line. So the tangent line could look like there, the tangent line could look like here, tangent line could look like here. So with implicit functions, tangents at x equals a can have multiple solutions. Depends on solution to f, or I want to say solution, the evaluation to f of a. So when dealing with implicit functions, implicit functions imply and is typically stated that y is a function of x. Okay? So it's implied that y itself is a function of x. So it's not necessary review, but before we get into the actual work on today's problem, I want to talk about finding y, which is of course f of a, or finding f of a. Let's look at an example. X squared y plus y squared equals 2. Now this is an implicit function right here. If x equals -1, find f of -1. Or that's terrible. That's terrible word. Find f of -1. State as coordinate. So this is a function like any other function, and this is what really it could be a little bit tricky. But there's going to be a lot of like system of equations type work that we're going to be doing. Not today necessarily, but in Friday, tomorrow, and Monday's material. There's going to be questions that are going to incorporate this idea of a system of equations. And typically the equation that everybody always forgets, or the relationship that we always forget, is the implicit function itself. So this is a relationship. It's an equation, but it's a relationship between x and y. Therefore, if we could figure out, if we have if all we have is one unknown, there's only one unknown, then we only need one relationship and one point. Okay? So and when we get into the future stuff, there's going to be a third variable, which is the derivative dy dx. And therefore, if there's going to be 3 unknowns, so we need to know 2 relationships and 2 points. Seems like if 2 variables, you need 1 relationship and a point. 3 variables, 2 relationships with 2 points. All right, so what do I do? And it should be fairly obvious. So I'm not asking a mind-blowing question here. That's what we're doing. We're finding y when x equals -1. What do I do?
Plug in -1.
Yeah, plug in -1. That's it. So -1 squared y plus y squared equals 2. And then we have an algebra problem. Okay, now the algebra problem typically on these cases is typically a quadratic, but it could just end up being linear in the end. So we get y plus y squared equals 2. And how do I go about solving that? What do I do? How do I solve this quadratic?
Can you factor?
Okay, yes, but how do I do that?
Oh, you take out a y and do your parentheses.
And that's why I don't say yes to the factoring. What do I do next? What is my next step? It's a common mistake that's made right there. It's probably the number 1 most common step, is we try to factor as is. It's just probably been a while since you've done this.
Minus y?
No. It is going to be the factor, but factoring is going to be the second step.
Is it going to be y squared plus y minus 2?
So the answer here is, remember, so this is a quadratic. And to solve quadratics, you typically set equal to 0. Unless vertex form. We'll get into those ones. Those are the real special ones where you can just do the algebra when you don't see y and y squared. Which means that So doing that, I get y squared plus y minus 2 equals 0. Always, always, always. There's nothing in terms of derivatives here. This problem has nothing at all to do with derivatives. This is just implicit functions. Nothing in here says anything about finding a derivative, so always don't think you're just doing derivatives of everything. So what do I do now?
You can factor in now,
yeah. Okay, how do I factor?
So y plus 2 and then y minus 1.
Good. And so y equals?
1y equals -2, and then another y equals 1.
So my answers would be -1, -2, and -1, 1. Okay. So in some of the problems, when I'm going to ask you to find the tangent line, or tangent lines, there might be more than one answer. All right, so this is a case where there could be more than one answer if I only give you the x value. If I only give you the independent variable x, find the tangent at x equals -1. Or if I even say find a derivative at x equals -1, you have to realize, whoa, in implicit functions, there might be two, I need to know what f of -1 is as well. So you might have to go through this process with the original implicit function. So with the implicit function, what do I do? All right. Now, the nice thing is that most problems in their most basic form will give you both the x and y coordinate, and it'll be one single tangent line. So finding the slope of the tangent. All right, so now we're going to start talking about derivatives. Now we're getting in terms of that. And there's a lot of ways of writing this. The most common way that we're going to be writing it is dy dx evaluated at a f of a. Okay, now this is typically what it's going to be asking you to do. It's going to find right here. And so, of course, this is an m, but it should be also known as find the derivative at x equals a, y equals f of a. Okay, so find the derivative slash slope. All right. Typically, I can ask you either of these two ways. Finding the slope, m, at x equals a, f of a, or more importantly, there's this notation right here, which we need to be comfortable saying that it's saying the same thing. I'm finding the derivative evaluated, that's what that line means, when x equals a, whatever that number is, and f and y equals that value, f of a. So let's focus first on finding slopes before we get into tangent lines. And let's do an example. Given that y is a function of x, that's what I said usually the problem states it. Find the equation, find the slope. We'll do it. Find dy dx at -1 comma -2. Let's get used to these notations right here. And my equation is y squared x plus 2x equals -6. Remember, everything has a purpose. The student who's going to pass the AP exam, the student who's going to get a 5 on the AP exam, is the student that always justifies why they are doing what they are doing. They are not just jumping in and saying, I'm going to do this, I'm going to, because the last thing we did we did that, so I'm just going to do the exact same thing. The reason why, first off, we did what we did up here was because we did not have the y value. In this problem, I clearly have the y value, -2. So if I try to do the same thing, I have it. Now, something to note here. This is a little bit extra, and I've seen this from AP teachers even. There's lots of instances where students will try to do the work. A teacher will assign a problem, and they'll get an answer, and then another student does a problem, and they do it in a different way, and they get a different answer. And then the question goes, how did and why is it true, and why do we get two different answers, and there's nothing wrong in the math? And well, first and foremost, this point here needs to be true. So in other words, -2 squared times -1 plus 2 times -1 equals 6. So wait, did I do this one wrong? Oh, equals -6. So that gives me 4 times -1 minus 2, which is -6, which gives me -6 equals -6. No need to check, but must be true. You'll be surprised at how many teachers, even when they try to create a problem, Don't check to see it's a point. It's a function. So when I ask you for a tangent, that tangent has to be on the line, on the curve. It seems like a duh type of thing, but some people just try to find a magical one and say, all right, we're going to find the derivative of this. Like, because in any other normal function, I can just say, find the derivative of x equals, and you can give me any number, -1, 5, 15, -17, and it's all you need. But with implicit differentiation, at least when I give you 2 points, it needs to be purposeful. It needs to say -1 and -2, that if I plugged in -1, I would get -2. And if I tell you that you can always assume that when you plug in -1, you would get -2. You don't have to check it. All right, what do I do?
You gotta change the equation into derivative.
Yeah, so I gotta find a derivative. I gotta implicit differentiate.
So for the y squared and x, you have to use the product rule.
Good.
So that'll be like 2y times x.
No.
Plus.
No.
Wait, I mean 2y y prime, or 2y dyx.
dy dx.
Yeah, dy dx times x. Okay, so let me do your plus. And then 1 times y squared. Oh, don't, and we have to do the 2, so plus 2 equals 0.
There we go. So that's basically what your previous homework is. We'll do a lot more examples, and you can see that if you didn't do your homework or if you didn't master implicit differentiation, then you can't. That's just now the first step in our problems. All right, so it's just step 1 is doing the derivative, doing the implicit differentiation. Now, I'm going to show you now. This is very important here. Okay, this is not the answer, but it is very important here because we can actually do 2 different things here. Now, I'm going to do this first one, which is not the efficient way. All right, the first method I'm going to do is not efficient. Now, I want to note nothing in this problem ask me to find dy dx. There is nothing in this problem that says find dy dx. The derivative function. So I am not required to find a derivative function. Does that make sense?
Yeah.
So when we talked about, when we were dealing with explicit functions, in order to find a derivative at a point, we first needed to find a derivative. Technically not true. The more proper way of saying it is in order to find a derivative at a point, I need to take the derivative. I don't necessarily need to find the derivative, I just need to take the derivative. Okay, so that's going to be the alternative one. It's going to go into there. All right, but let's do this one first, a more traditional way. All right, just like you did in your homework. All right, this was your homework last night. We want to find dy dx. I would get 2xy dy dx equals -y squared minus 2. Therefore, dy dx is equal to -y squared minus 2 all over 2xy. I'll circle that. That's just me finding that derivative, solving for dy dx. Nothing different than what you did on last night's homework. Nothing different than you did on Tuesday, that we learned on Tuesday. And what am I going to do now? What am I going to do now?
Can't you plug in the -1 to the x's and then the -2 to the y's?
Perfect. I just plug in these numbers in. And so I get dy d. And I'm not going to be a stickler here of you writing this left-hand part. All right. You can write this as m. You can write this as that. You can even write this as, I'm not going to be a real big stickler if you wrote dy dx. All right. There's a lot of different ways that you can write the left-hand side. You know, we're just going to find the answer. All right. The proper way of saying it, I want to note that the proper way of stating this is this. Oops. Is this. This is the proper way right here. All right. There's no questions about it that it's going to be the proper way of doing it. But if you did either of the other two, I'm really not going to be too much of a stickler on those ones. So we're going to plug it in. Just make sure you plug in correctly. -2, -2 squared minus 2 over 2 times -1 times -2, which gives me -4 minus 2, which is -6 over 4, which gives me -3 over 2. So that's my answer. -3/2 is my answer. Now, the alternative method is just to plug in right after differentiation. So in other words, I'm going to plug in directly from there. I'm not going to find a derivative. Now, which method is correct? They're both correct. You want to be comfortable in terms of doing it. This is what's more efficient for it, and oftentimes can be the right answer. So what I'm going to do is I'm going to do 2 times -2 dy dx, or you can put m in there as well, y prime if you want to, times -1 plus -2 squared plus 2 equals 0. This can be very helpful if there's a lot of steps, because when doing the other one requires that you found dy dx function correctly, which means that can be multiple steps, which means you could also make a mistake. And sometimes the problems get really ugly to do. All right, so that's 2 times -2, which is -4 times -1, so that gives me 4. I like to put m, it just lets me make the problem easier. Plus 4 plus 2, so that's plus 6, equals 0. 4m equals -6. So m equals -6 over 4, which is, of course, -3/2. If all I am finding is the slope and the function is not, the problem does not state find dy dx, then I'm going to go there. Now, if typically on the AP exam, though, they're going to stay to find dy dx as one of the parts. So one of the questions will be to find dy dx, or might even say show that, and they'll tell you what dy dx is. Okay. Tangent lines. Really, nothing special now that we know how to do this. It's the same formula. Y minus f of a equals f prime of a times x minus a. Now this is the same. However, we have to realize that f prime of a is its own problem, and that f prime of a is really dy dx evaluated at a f of a. But in terms of notation, this can still be considered a problem. It just means that you need to find the slope at a, at x equals a, and y equals f of a, which also, once again, might require you to find f of a using the original implicit function. Find a tangent from previous problem at given point. Okay, so same problem. We already know the slope is negative 3s. So we know that x equals -1. We know that y equals -2. And we also now know that the slope is -3/2. So my answer is rather straightforward. What is my answer? This is all just requiring plugging in now. This is just plugging in tangent line.
F prime of A, it would be -3/2.
Yeah, we already got that. Yeah, that's what I'm saying right there.
I just wanted to put those things in the equation.
Yeah.
Oh, so wouldn't it be like y plus 2 equals -3/2 parentheses and x plus 1?
And that's it. So when the question asks you for a tangent line, I really want you to let you know it's just the same thing. Now, you have to be able to do all the other stuff, right? We have to be able to differentiate implicitly. Then we have to be able to plug in the points, the x and y coordinates, into that derivative to find the slope. After that, there's no difference in regards to finding the tangent line. It seems like all these extra things I would have to do, but in reality, I don't have to do much to do the problem. Now, in the previous example, in the first example, I gave you the relationship x squared y plus y squared equals 2. And the problem would say something like, find the tangent with a parenthesis, so there might be more than one, at x equals -1. Okay? Well, in doing this problem, we would follow the same steps we just did before. So we would have done that -1 squared. So we need to figure out what is the y value. Plus y squared equals 2. We did the work and we found out that we got -1 comma -2. And we got -1 comma 1. So we did this work now. Okay? So now I need to find, there are 2 tangents to my problem. Okay, so if there's 2 tangents, that means there are 2 slopes. Make sense? So x squared y plus y squared equals 2. I got to find a slope. How do I find a slope?
Wait, what was the question?
How do I find a slope? How do I go about doing this problem?
Or would you wait? Would you have to do the y minus f of a equals f prime of a.
I could write that down.
Or
What do I do?
what, you have to change it, the x squared y plus thing back to its derivative form?
Yeah, it's not changing it. Okay, when you say change, that's the algebra, right? When we talk about changing, it's algebra. But we got to differentiate. So the first thing we have to do is we have to differentiate, which is really implicit differentiation, but it's just differentiating. We just got to take the derivative now. We have to find the tangent. We have to find the slope. That means we have to take a derivative. So what do I get?
It'll just be, oh, you have to do the product rule again. So it's just 2x, 2x y prime?
No.
No, 2xy plus y prime.
Okay, I'll use the y prime notation this time in the notes.
Oh, my bad.
No, it's fine.
X
It's fine. There's nothing wrong with it.
X squared, and then plus y squared equals 0.
No.
I meant 2y times 2y y prime equals 0.
So Ariana wants to do this problem using y primes. It's perfectly fine. I've been doing my notes. I'm going to show the y prime in this example, and I'll try to go back to probably using dy dx's. I'm a fan of the dy dx notation. Nothing wrong though against this one, and I want to show that. All right, what do I do now?
And then don't you have to plug in the x's? Oh, you can do the derivative.
So no, we've already done the derivative. So the most efficient way is to plug in now. All right, just to plug in now. Now, the problem here is that we have 2 points. We have -1, -2, and -1, 1. So we have to find 2 slopes. So we have to do 2 problems. So I'm going to plug in 2 times -1 times -2 plus y prime times -1 squared plus 2 times -2y prime. Ooh, I ran out of space there. Equals 0. Okay, I'm going to do that one first. That gives me 4 plus y prime minus 4y prime equals 0. That gives me 4 minus 3y prime equals 0. 4 equals 3y prime. So y prime equals 4 over 3. And therefore my first answer is what? What is my first answer?
Where to speak for the equation?
Mm-hmm.
For this, so it'd be like y plus 2 equals 4 over 3 parenthesis and then x plus 1.
Good. We're not done yet though. Just gotta do the other one.
Do the other side?
Yep. So now on the other side, 2 times -1 times 1 plus y prime times -1 squared plus 2 times 1 y prime equals 0. That gives me -2 plus y prime plus 2 y prime equals 0, which is -2 plus 3y prime equals 0, which is 3y prime equals 2. So y prime equals 2 over 3, which gives me to my second answer, which is
y minus 1 equals 2 or 3, parentheses, x plus 1.
Two answers. Your homework tonight is Delta Math, but I do want to point out that your next following two homework assignments are actually going to be homework handouts. So you're going to be doing some more practice and demonstrations of actually doing out the work. Take the Delta Math homework last night. Not all of you turned it in. So make sure that you're the one that homework for the Delta Math that was due today. You really can't do tonight's homework unless you understood how to do that homework. So for those of you who are not taking advantage of the tutorings or are not showing up to the tutorings that you have already signed up for, which is even worse, then you're setting yourself to go further and further behind. We can't do that. Everything right here on this unit, as you can see, builds. What we're going to do tomorrow builds on what we've just done in the past couple of lessons. What we're going to do on Monday is going to build on all the previous lessons and so forth. So we will be moving away from implicit differentiation in the unit afterwards, but it will swing and find its way back in, especially towards the end of the course. Implicit differentiation becomes a major topic once again. I know it always never goes away. So just in case, in terms of just noting, hopefully you've been, your attendances, hopefully let me pause.